Hi everyone. I hope you all will stay warm and safe during this time. I know right now the roads aren't bad, but tomorrow they probably will be. And so we just had our test on sections 4.1 through 4.5. So this is introducing the next section, which is 4.6. And it's on solving rational equations. So if you remember, the word rational means something that's a fraction. So we're going to have fractions in equations that we're going to deal with. And we're going to start simple with this, just so you guys are aware. This video will be a little bit longer because I want to give you lots and lots and lots of examples. And some of you may feel like you get it after just the first couple of examples, and you can just kind of move on. Others of you may need to see more examples, and near the end of the video I'll actually work through page 247, numbers 5 through 7, and I would encourage you to pause the video, try to work the problem yourself, and then maybe play it and see if you did it correctly. So we'll kind of do guided practice with that. Okay, so now what is a rational equation? We'll start simple. I said it's going to involve a fraction. So rational is something that can be written as a fraction. Sorry, I had a little slip up there. So let's start with example 1, which is on page 243. So suppose that we have an equation that looks like 45 equals 1700 over d minus 33. Now, if you notice, this one on the left is not a fraction, so this is probably the easiest type that we'll have. But if 45 is not a fraction, we can make it a fraction by putting it over 1. The way we're going to solve rational equations is by multiplying both sides by the least common denominator, which means that we want the denominators to be the same. Well, right now, this is 1. We want this denominator to look like this one, d minus 33. So we're going to multiply both sides by d minus 33, and this side by d minus 33. What happens is the d minus 33s will cancel on the right-hand side, and because this is also over 1, we're left with just 45 times d minus 33 equals 1700. Now, some of you may recognize this. If you have left-hand side equals right-hand side, there's nothing else going on, you can actually cross-multiply, which is getting you the same exact answer. So for something simple like this, cross-multiplication works. And so you would get 45d minus 33 times 45, and I should have my calculator on me, and I need to grab that real quick. Okay, sorry about that. It is 1485. And now at this point, it's a simple equation you are all used to solving. We would add 1485 to both sides, and we get 45d equals 3,185, and so d equals 70.8 approximately. So this is the most simple type of rational equation where we can just cross multiply or just multiply both sides by the one denominator. Well, what happens when it's a little more complicated, where we have fractions on both sides, addition and subtraction going on in our fractions? So I'm going to start actually without x's and variables like that. If you guys remember way back to when you learned how to add fractions, if we want to add 2/5 to 3/4, these two do not have the same denominator. So you learned how to multiply, well, the least common denominator by this would be 20. And so you multiplied this one by 4 over 4 and this one by 5 over 5 in order to get the same denominator. This would be 8 over 20 plus 15 over 20. And then once you get the same denominator, you can just add the numerators. Well, we're going to actually do the same thing with an equation. So now, say that I have the equation x over x plus 4 minus 2 over x minus 1 equals 20 over x squared plus 3x minus 4. So what's going to happen is, if you notice on the left-hand side, we have two different denominators, x plus 4 and x minus 1. So what I'm going to do to the x plus 4 denominator fraction, I'm going to use x minus 1 and multiply both numerator and denominator by x minus 1. And I'm going to put parentheses around that. Now, I'm going to take the x plus 4 and multiply that times this fraction. Now, at this point, some of you may be wondering, well, that's good for the left-hand side. I see that both denominators will be the same. But what about the right-hand side? If you are wondering that, if you take x minus 1 times x plus 4, and do this off to the side, hopefully by now you see that this is something that could be FOILed. Well, this FOILs out to x squared plus 3x minus 4, which is that right-hand side. So actually, now everything has the same denominator. So we have to actually use the distributive property to multiply everything out. So for this first fraction, I'm going to get x times x, which is x squared. I'm going to get negative 1 times x, which is minus x. And that's all over that denominator, which is x squared plus 3x minus 4. Minus 2x, and 2 times 4 is 8, all over x squared plus 3x minus 4 equals 20 over x squared plus 3x minus 4. Now, you may have done something like this in Algebra 2, and once you have the same denominator everywhere, we actually don't need it anymore. We can cancel it out from everything. But we need to be careful. If you notice, this is subtraction, and we're subtracting this entire fraction. Fraction bars are kind of like parentheses, so we need to have a parenthesis here, which means we're really doing x squared minus x minus 2x plus 8 in parentheses equals 20. So using the distributive property, this is minus 2x minus 8. So we get x squared minus x minus 2x is minus 3x, and then we get minus 8. Well, now at this point, we can actually subtract 20 from both sides, and x squared minus 3x minus 28 equals 0. Hopefully at this point, you realize that this is something that can be factored. This is x, 7 and 4 will get you this, and so this is x plus 7 and x minus 4. So in this example, our solutions are going to actually be 4 and negative 7. Okay, so some of you may feel like you have this, and you can either skip ahead and try to work out some of the guided practice problems, or you can try to jump into your homework and maybe come back to the video if you're having trouble. So now I'm going to go through example 2, which is on page 244. If you are good at following book problems, then you can skip to the guided practice. So this problem is very similar to the last one we just did. This is a plus a squared minus 5 over a squared minus 1 equals a squared plus a plus 2 all over a plus 1. So now we need to make a common denominator just like before. And the first thing you notice, hopefully, is that this one is probably going to be our final denominator because it has the highest power. And so I'm going to at least start by making sure everything has an a plus 1. Well, hopefully you remember that a squared minus 1 factors out to a plus 1 and a minus 1. So if you want to think of this as a plus 1 and a minus 1, it already has the a plus 1. So I need to multiply this one by a plus 1 times a plus 1. This one already has an a plus 1 in it, and this one already has an a plus 1 in it. But if you notice, since this factors out to a plus 1 and a minus 1, I also have to consider that every term needs an a minus 1 in it, which means that this right-hand term needs to be multiplied by a minus 1 up top and in the bottom. And this left-hand term also needs an a minus 1. And I kind of ran out of room. So the cool thing is that once you've known that the denominators are the same, you don't have to actually multiply these out. If you do, you're going to get a squared minus 1. So those are going to cancel once the denominators are all the same, and I have to multiply this out. Well, a plus 1 times a minus 1 is a squared minus 1. But I still have an a that I need to multiply by. And then I have this a squared plus 5, sorry, a squared minus 5. And if you want to be careful, you can always put the second numerator in parentheses. Equals, and then I have to multiply this out. Now this, if you remember, is a trinomial times a binomial. We're going to have 6 terms that come out of this. We're going to get a cubed plus a squared plus 2a minus a squared minus a minus 2. And simplifying this, we have to multiply this out, which is a cubed minus a plus a squared minus 5 equals, combine like terms on the right hand side, a cubed, a squared and minus a squared cancel, and then we get 2a minus a, that's plus a, and then we get minus 2. You may look at this and be like, I don't know how to solve this, but since we just solved things where everything had to equal 0, I'm going to move all of this stuff over here by subtracting it. So subtract a cubed from both sides, subtract a from both sides, and add 2 to both sides. What's going to happen is those are going to cancel, those are going to cancel, those are going to cancel. A cubed minus a cubed cancels. On the left-hand side, we're left with a squared minus 2a minus 3 equals 0. Well, this looks much better. We can factor this. This is a minus 3 and a plus 1. So our solutions are a equals 3 and a equals negative 1. So we're kind of combining our factoring skills with now this new fraction technique. So now I want to go through guided practice of page 247, numbers 5 through 7. Some of these are easier and some of them are harder. So what I would like you to do is I'm going to put the problem up, and then you can pause it, try to do it on your own, or kind of go back and forth between pausing and you trying the next step. So the first problem is a minus 5 over a equals 4. So again, we want a common denominator. This is over 1. So we have to multiply this by a over a. And if you notice, the right-hand side is also over 1. So I need to multiply this by a over a. So we get a squared over a minus 5 over a equals 4a over a. Once we have the same denominator, we can get rid of them, and we're left with a squared minus 5 equals 4a. We need to get this equal to 0, so I'm going to subtract 4a from both sides, and you're left with a squared minus 4a minus 5 equals 0. Now this is easily factorable. We get a minus 5 and a plus 1. So the solutions are 5 and negative 1. So this was, sorry, number 5. Number 6 is 9 over b plus 5 equals 3 over b minus 3. So if you notice, this is a type of problem where you can just cross multiply. But to be more general, I'm going to multiply both sides to get the same denominator. So because this side does not have a b plus 5, I'm going to multiply the top and the bottom by b plus 5. And then on the left-hand side, I don't see a b minus 3. So I need to multiply, I have to erase the 6 that I wrote here. I have to multiply this side by b minus 3. So on the left-hand side, I get 9b minus 27, don't forget to distribute, equals 3b plus 15, don't forget to distribute. And because the denominators are the same, b minus 3 times b plus 5, b minus 3 times b plus 5, I'm not even going to bother writing it out. Now it's super easy to solve. I'm going to move the 3b to the other side by subtracting to get 6b minus 27 equals 15. Add 27 to both sides. 6b equals 42. And divide by 6b equals 7. This one only had one solution. Okay, now we'll do number 7. This time I'm trying to leave more room for myself. This is t plus 4 over t plus 3 over t minus 4 equals negative 16 over t squared minus 4t. So usually what's going to happen is the one with the highest power will end up being the least common denominator. We can think of t squared minus 4t as being the same thing as t, remember we can factor out a t, times t minus 4. Well, those are the same two denominators we see on the left-hand side. So we need to make the left-hand side have the same denominator as this. So because this already has a t, I need to multiply it by the missing part, t minus 4, and multiply the top also by t minus 4. And then this one is missing a t, so I'm going to multiply by t up top and multiply by t in the bottom. So now if you noticed, I have t minus 4 times t minus 4 times t, and that ends up being the same as t squared minus 4t, so I have the same denominator already. FOIL these two together. This is a special product when you have x minus a number, x plus a number, or t minus a number, t plus a number. You get t squared, the first thing squared, minus the second thing squared, 16, plus 3t equals negative 16. So now we just need to move everything to one side. T squared plus 3t. We're going to be adding 16. So what happens is that minus 16 actually cancels on both sides, equals 0. Now we can factor out a t. And don't forget that this t all by itself is a solution. T equals 0, and t equals negative 3. And that's it. So now you can either, well, some of you have probably not watched to the end, but now you would work on your homework, and I have posted that on Moodle as well. And stay tuned for tomorrow, and I'm anticipating that we may not have school Thursday as well. So we'll continue this. I'll send out an update email about what to expect from me